Hello everyone, this is Muhammad Afifi from ConexTech. We are demoing today our latest version of TCP M-Adaptive Transmission version 2. The setup we have is that we are connected to a Wi-Fi, and the Wi-Fi signal is intentionally degraded. It affects the performance. The Linux kernel we are using is 6.17.0 as we are gonna see right now. We are using this version which has all the updates and upgrades to the Cubic and Google BBR we are going to demo against. Let's get started. So that right now our technology is 1.9 megabyte per second, while Google BBR is 59.9 kbyte per second, and Cubic is 36.6 kbyte per second. Our technology has uploaded over 15% already. Now, Google BBR and Cubic is one of the leading state-of-the-art congestion control algorithm in deployments. They are used very widely. Cubic is used among Microsoft and Apple alongside other big tech companies, and Google BBR is used by Google and Starlink for internet satellites. They both dominate the internet sector for transmission control protocol deployments. Our congestion control algorithm, one of the main advantages of our technology is that it's a server-side only implementation, which doesn't require client modification or modification to the infrastructure. You can deploy it only on the server, and you have all the best system benefits immediately to all clients connected, millions of clients connected around the world. They don't require software update or hardware modification, just implemented on the server. And one of the main advantages of our technology is that it differentiates between a poor signal for the internet and a congestion. So it's proactive to the congestion. It detects congestion ahead and reduces the rate. And in case of poor signal, it doesn't decrease the rate like Cubic and Google BBR with other state-of-the-art congestion control algorithm, which has a bottleneck for detecting the difference between a congestion and a poor signal. So now momentarily our technology is stale, which means it's gonna decrease probably because there is congestion ahead. Let's see. Google BBR is 1.5 kbyte per second and Cubic is 22.4 kbyte per second. The congestion control solutions component of the transmission control protocol, which is used for reliable data transfer over the internet, and it's used over 90% of the internet traffic, decides silently the transmission rate of the connection. So this component is introduced originally because of congestion collapse. Imagine if all the connections around the world connected to the internet has all the same speed at the same time. The intermediate devices like routers and towers and the infrastructure for the internet will be overwhelmed with data, so they will collapse. So the transmission control protocol is responsible for adjusting the rate based on the congestion state of the network. But the problem is that there is no explicit signal stating that this is a poor signal or this is a congestion. So the poor signal and congestion confuses a lot of congestion control algorithm because they have similar feedback, such as high delays and high packet loss. So the leading state-of-the-art congestion control algorithm like Google BBR and Cubic confuses the board signal to the congestion, and they degrade the performance of the connections unintentionally, which one of the bottlenecks for Google BBR for a congestion control component of the transmission control protocol. Now our technology is 1.4 megabyte per second, and it's over 90%. And Google BBR is 2.9 kbyte per second, and less than 0.20 percent has been uploaded, while Cubic is 12 kbyte per second and less than 1% has been uploaded. The file size we are using is 438.9 megabyte per second. It's identical for all three flows. Thank you for watching.